Manufacturing Engineering by Zach Oken and Jackson Smith. What they do. Manufacturing engineers design, integrate, or improve manufacturing systems or related processes. They troubleshoot new or existing product problems involving designs, materials, or processes, and they investigate or resolve operational problems such as material use variances or bottlenecks. They identify opportunities or implement changes to improve manufacturing processes or products or to reduce costs. This is done by using knowledge of fabrication processes, tooling, and production equipment, assembly methods, quality control standards or product design, materials, and parts. Apply continuous improvement methods such as lean manufacturing to enhance manufacturing quality, reliability, and cost effectiveness. So some current job opportunities for manufacturing engineering are, first of all, an entry-level one is at Two Roads Professional Resources Incorporated. This is a full-time job at Chandler, Arizona, and it's a junior to mid-level job. The experience level job is Universal Laser Systems Incorporated, which is also a full-time job in Scottsdale, Arizona, and that one requires experience. So now that brings up how much they make. So the average salary for a manufacturing engineer is $99,410 per year. An entry-level manufacturing engineer is $69,890 per year, where an experienced level manufacturing engineer is $126,200 per year. The hourly wage for a manufacturing engineer is an average of $47.19 per hour, with an entry-level manufacturing engineer making about $25 per hour and an experienced level manufacturing engineer making $64.50 an hour. So the degree requirements for a manufacturing engineer is a bachelor's degree. Now, because this manufacturing engineering bachelor's degree is not offered at every college, some of the most popular majors for it are engineering general, architectural engineering, chemical and biomolecular engineering, geotechnical and geoenvironmental engineering, polymer science, laser and optical engineering, mechanical engineering, and lastly, the actual manufacturing engineering bachelor's degree. So 70% of manufacturing engineers said they're satisfied with their job, which is very high for job satisfaction. Which brings up the pros to being a manufacturing engineer. Manufacturing engineering pros are that it's suitable for people who like practical and hands-on work. It's suitable for people who want job security and a good working condition. It's perfect for people who love to work indoors, since most of it's done in factories or indoor spaces. It has a very high salary, which is the top 25% highest paid careers. And the employment of industrial engineers is projected to grow 8% from 2018 to 2028, faster than the average for all occupations. So the cons for manufacturing engineers, the fact that it's not suitable for people who love to help and teach others, since it's very personal and like a solo job. It's hard to get in this career. A considerable amount of work-related skill, knowledge, and experience is required for this career. It also has very long working hours. Most of the time, it's over 40 hours per week. Which brings up, what does a typical day include? A typical day being a manufacturing engineer includes preparing reports, summarizing information or trends related to manufacturing performance, to troubleshoot new or existing product problems involving designs, materials, or processes, to supervise technicians, technologists, analysts, administrative staff, or other engineers as they work on manufacturing an item, or provide technical expertise or support related to manufacturing, as well as preparing documentation for new manufacturing processes or engineering procedures. So now, let's watch a short video.
Day in the life, manufacturing engineer. In my third year out of college, I entered into the final position for my rotation program, manufacturing engineering. This is the position I would end up accepting full-time. In this position, I work for another manufacturer for small components used all around you. These products can be found in anything from bikes to planes. My role here is to support our operations team in all of our technical needs. From providing drawings to planning out a project for machine improvement, I am involved in all aspects of manufacturing. 7:30 a.m., I get in my car for a 30-minute drive to work in heavy traffic, still dreaming of the days when I was biking. 8 a.m. I get to work and check my email and voicemail. Before I'm done with this, someone has likely contacted me to ask for something urgent. For example, 8:05 a.m. I get a phone call from someone on the shop floor saying a piece of equipment broke or did not work properly last night and needs attention. Could I please come down and check it out? Since they're calling me, that means the issue has something to do with a program, machine setting, or broken tooling to reorder or redesign. If the issue is a machine-based fix, they would call maintenance instead of me. 8:10 a.m. After getting my PPE, personal protective equipment, put on, I head out to the floor. On my way down to the operator who called me, other operators stop me with a request. Many times they will be asking me for a drawing update or router update. Sometimes I'll need to ask them to wait until I can come back from the task I'm already working on. Most operators in our shop respond to this with a typical, "Oh yeah, they run you engineers all around this place." 8:20 a.m. Hopefully by this time I've made it down to the operator who called me first thing in the morning. I'll examine the equipment they are talking about and ask some key questions about what is going on. When did this happen? What was going on when it happened? Who witnessed it? Who have you talked to about this since? What were they doing? Were there any other pieces of equipment affected? When does it need to run next? If I've done a decent job handling my relationships with the operators, I'll usually get answers to all of these questions and more. By the time the conversation is done, I have a full docket of action items to take back to my desk. Sometimes I'll need to form a team or contact one or two other people to help solve the problem. Other times, I'll just need to get my information straight before sending a request out to a supplier. Of course, I hardly ever make it back to do those tasks without running into at least one other person who needs other technical help. 9:30 a.m. I've completed a walk around the shop floor, responding to and accepting new requests, and I'm hopefully back at my desk to get some work done on these requests. Many times, requests will spark new ideas in my head that I'll work to initiate. Thus, the realm of things I work on includes both newly initiated projects and responding to quick needs of others. I like this range because it gives me the ability to both be creative and busy for others. 10 a.m. I probably have a meeting now, or at 11 a.m. I have to put aside what I'm working on and attend in order to provide either updates or get answers for projects in a collaborative setting. This routine of stopping desk work, going to meetings, resuming desk work, stopping desk work, going to the shop floor, resuming desk work, stopping desk work, going to meetings, usually takes up my whole day. I don't even break for lunch on most days. I take the quiet time to get some work done at my desk. On Fridays, I do go out for lunch with as many of the engineering team that will come, taking an unusual hour-long break. While I'm working at my desk, I'm usually working on longer-term projects. These usually involve new products to be produced on the shop floor, machinery improvements, and process improvements. These types of introductions and improvements go through 7 phases: ideation, justification, approval, design, ordering, commissioning, and a final evaluation. That first phase, ideation, coming up with what we need and why. Usually someone at the company will say, "Wouldn't it be great if we had this?" That small statement is the beginning of months of work. From that statement, I'll usually work on collecting data about the current state of our manufacturing around that idea. How efficient is the work? How safe? How much does the work cost? Phase 2, justification. Once we've collected data on the current state, I'll research into how the change would impact the current state. Will the cost decrease? Will it remove working hazards and improve our safety? Will it make us more efficient? How much more efficient? Does that improvement justify the cost and time to design, purchase, and build this new thing? Phase 3, approval. When the justification has been calculated, I'll work on getting the approvals necessary to make the purchase. For many projects, this means submitting a CapEx, short for capital expenditure. Essentially, I submit a report that describes the idea, cost, and justification so that anyone can understand our goal and either approve or disapprove the project. Phase 4, design. When we have received approval to move forward, I'll really begin working on the design details. SolidWorks and AutoCAD are good friends here, as well as salespeople from other companies. I can call in a company that specializes in the process or machine I'm working on to present their solutions and help us move towards a streamlined answer for the problem. Purchasing something already in existence is always easier than designing from scratch. It's also helpful for troubleshooting later on when something goes wrong, because there's a whole team of people outside the company who can give ideas about how to solve the problem. Phase 5, ordering. Once the design has been fully developed, I'll put in a PR, or purchase requisition, to order whatever we need to build the final equipment. The purchase department will take that requisition and build a PO, or purchase order, off of the details. If they think we can find a better price, they'll usually recommend another company for me to order from or send over cheaper models to consider. When the PO has been sent to our supplier, it's time to wait for the new equipment to arrive. Phase 6, commissioning. When the equipment has arrived at our facility, it needs to go through a commissioning process. This is the process by which we prove the equipment's operability and effectiveness. During this time, work instructions are finalized, maintenance schedules are developed, job safety sheets are created, and operators are trained in proper use of the equipment. This process is critical for prolonged success with the equipment. Phase 7, final evaluation. After the full project is completed and the new equipment has been running for a month or so, data is collected to prove the impact of the new equipment. This data will be presented to any members of the team involved in the machine's setup, as well as the company management. The review will allow the team to look back and either congratulate each other for a job well done, or create a lessons learned session to prevent any hiccups from occurring in the future. While following these steps, there are various structures to help guide the decisions and organize the information for the project. My favorite is to follow the Six Sigma DMAIC structure. This structure helps guide the project team through steps of data collection and analysis for better decision making. Along the way, the team can also use Pareto charts, Gantt charts, and Ishikawa diagrams to move the process along. These charts aid in the communication and analysis of information. In one day at my desk, I'll likely touch on a few of the steps in the project process for various projects going on at the same time. For one project, I'll receive and review a quote, communicating the quote with other project team members. For another project, I'll work on the design of what we need. For a third project, I'll be charting data collected the previous week to present to the project team. This variety keeps me happily busy, though the multitude of projects can be overwhelming sometimes. In a job like this, being able to step away at the end of the day and relax is extremely important for long-term success and happiness in the job.
Now that you watched a short video on Manufacturing Engineer, we have some more resources if you want to learn more. The first website is recruiter.com, and this is where you can learn about the salaries of manufacturing engineers and different job stuff that it has. The next one is getreskilled.com, which is what is a manufacturing engineer. The third one is mime.oregonstate.edu, which is Oregon State University, which is what their manufacturing engineers do. The fourth one is engineering.unsw, which is University of Northern South Wales, and that is about, in Australia, it's about what mechanical engineering and manufacturing engineering do when they study there. And the last one is Owl Guru, which is all about the career of manufacturing engineers. So thank you very much for watching this presentation. Have a great day.